Hey coffee roasters, welcome to what I'm calling my quick release turbo oven drum roaster. As you can guess, this is a drum roaster powered by a turbo oven. So we'll be going over my design goals for the machine, some basics of its construction and how it's used, as well as a roasting demo at the end. Now I just want to note that this is not a build video. My goal here is to get more ideas out into the DIY coffee roasting community with regards to using a drum for roasting. I feel that this is the best way to roast coffee, and I simply haven't seen any other machines in this small scale format using a drum. So let's get into it. So I had 5 design goals with this machine. To be able to roast 1 pound of greens at a time in a drum with a turbo oven in a well-insulated container where the drum is very easy to remove when the roast is finished. So to elaborate on those points, I want to be able to roast in 1 pound increments simply because that's the increment at which I buy beans. It's a lot easier that way. As I said before, I feel a drum is the best way to roast coffee. A turbo oven because this is a cheap and easily accessible source of power that only requires 120 volts and isn't very loud. Next we have the main feature of this machine being that the drum is easy to remove from it. Here's a quick demo. So with my previous drum roaster, the rod going through the center of the drum went all the way through the machine, forcing me to pull it out like a skewer. And while it was simple to build, it was not convenient to remove at the end of a roast. So here's the drum inside, mount it up, and when I'm done with the roast, I just lift and pull. This was inspired by my Beemore, which had, of course, another drum, and it was very easy to remove from the unit. I wanted the unit to be well insulated, just to maximize the power produced by the turbo oven. Other units that I've made in the past get really, really hot, and that just means that there's heat going off into the environment inside of the beans. And finally, for the interesting part, some details of how this machine actually works. And I'm going to start with the quick release action. So it's simply a combination of a 1/4 inch bolt, which, as we all know, has a 7/16 inch head from flat to flat, along with a 7/16 inch drive socket. Now, when I insert the bolt into the socket, notice there's still quite a bit of play from side to side and up and down. What that lets me do is to insert the drum at an angle onto the drive bolt and drop it down into place. Then similarly, when I want to remove it, I just need to tilt it up a bit and pull it out of the machine. So here's the drive bolt over here, and here is the little hook thing over here. You'll see more of that in detail in a bit. So all I need to do is drop the drum in at an angle, slap it onto the bolt, and then click it into place. I'll quick fire it up for you. It works. So when I'm done roasting, I just tilt the drum up a little bit, pull it off the bolt head, and I'm done. So here's the little hook. So this is directly opposite of the drive bolt, and it's simply a small piece of aluminum bent into sort of a U or an L shape with a semicircle taken out of it. Then over on the other side, we of course have that 1/4 inch bolt sticking through the wall. Now on the drum, the main shaft going through the drum is simply a piece of 1/4 inch stainless steel square stock. And this is the side that works with that little hook. I put this on my lathe and just file down around for the hook to ride in. And then over here, all I did was to JB weld the drive socket onto the 1/4 inch shaft. Now 1/4 inch shaft was a very fortuitous material choice because not only does it perfectly fit through the square hole in the drum, it also fits nicely into a 1/4 inch drive socket. Now, I was going to remove this motor for you to show you how exactly it all fits together, but I sheared off my itty bitty 2mm hex key in the motor couplet. So I will be doing the focus and pray method here. So here's the drive motor. This is a 14 watt, 30 RPM gear motor. And with a couple pieces of aluminum and a piece of plywood that's mounted onto the side of the machine. And so this motor's output shaft is 6 millimeters. So way down in here, you can see there's a flexible coupler right here, the silver bit in the middle. And that flexible coupler is 6 millimeters by 1/4 of an inch. And all I did was drop that 1/4 inch bolt into the other side of the coupler. It's a very, very simple drive mechanism. And one piece that might be a little bit hard to see, but surrounding the bolt and sort of protecting it from the aluminum walls is a bronze bushing. It has a 1/4 inch inner diameter and a 3/8 of an inch outer diameter. And again, photos and more description of all this stuff is on my article. It's much easier to see everything in static pictures than trying to interpret this video. So on to the construction of this thing. This is a double walled pot. That's all it is. So I went with making a custom enclosure just so that I could minimize the air space around the drum, and to lose less heat and to have less surface area on the vessel. It was probably too complicated of a decision. And it certainly was a bit of doing to make this enclosure, but it's very well insulated and works great, so who am I to argue? So the crux of it are 2 of these aluminum plates that I made on my lathe. I sort of figured out how to do metal spinning at least well enough to make this sort of plate. So there's 2 of these things, one at this diameter and then of course one at the inner diameter. And they're nested inside one another and offset by 1 inch. And then I took two longer strips of aluminum and then wrapped them around the edges of the plate. You can kind of see the curve of the plate down here in the bottom. So these 2 long strips form the inner and outer walls. Everything's pop riveted together, and I made 4 chintzy feet for it. And the last complicated piece of the build was figuring out how to encapsulate the top at the intersection of those 2 plates. So there's some more videos photos on my write-up, and I made this kind of complicated Bart Simpson haircut looking strip. If I had to do it over again, I might try to imagine a different way to keep the chaff and stuff out of here, but it works well enough. Welcome to my basement. The roaster's been preheating for a few minutes. The turbo oven has cycled on and off a few times, so that tells me that it is all ready to go. And the turbo oven is set all the way up, which on the dial says 480 degrees Fahrenheit. So I have here 1 pound of greens. We're going to do them all at once. So I always orient the drum so that the lid is facing up. It's easy to use. Turn it on, make sure that the door is going to behave, and it does. Ready to go. So I'm going to leave it at 480 for basically until first crack starts to happen. Then I turn the dial down to maybe 440. That seems to reduce the tendency for a rolling first, second crack. Well, that's the roast. There's a view inside the chamber. There's the two cute little chaff piles it always leaves. I hope this video was helpful and informative. If you have any questions or comments, please leave them down below. Thanks for watching.